Hi, everybody. Welcome back. I hope that you were able to learn a lot about developing psychology experiments using the coder in PsychoPy today. For our wrap-up video, one of the things I wanted to do is actually show you what a finalized neuroimaging experiment looks like. So to do that, I'm going to go ahead and share my screen and just show you a task that we've developed in my lab to examine whether people are more likely to donate to positive or negatively valent Instagram posts and how much people like those different types of posts. One of the things I want to note before I run this demo is that the script itself is set up to work specifically with the computer that connects to the MRI here at Temple. So some of the image sizes are going to be wrong. The text placement is going to be off, but that's because it is designed to work with that computer, not my own. So I always recommend testing your script once it's ready on the specific experiment computer or computers you're going to be using. And after I give you a really brief demo of what the task might look like, I will go ahead and show you kind of some key components of the code that I didn't get a chance to cover during the workshop today, but I think is useful for neuroimaging experiments and for developing experiments in the coder. So let's go ahead and take a look at what this might look like. Awesome. So I'm just going to share the second screen here and kind of go through this task. So here are the task instructions, and then we're having the participant read through those instructions in the scanner. I'm going through them really quickly for the sake of time today. So this is a sample task that participants used. You can see that the timing here. Going through it, and then we're just telling participants which buttons they need to be pressing so that they can understand the control box. These are the task instructions. So the actual task we probably won't get to, but that's okay. And one of the things I think you want to do when you're watching this is just try and imagine like what the code might look like on the back end of this task. So you can see we have some responsive feedback based on participant responses. There's different timing variables going on. And then this screen is something that I always recommend people have during their imaging experiments, that you can sync your timing up really perfectly. I call this like a waiting screen or an experimenter screen. So this screen will not move forward without the press of a spacebar, which is something that the experimenter has to do. It's something that the participant cannot do while they're in the scanner. They can't accidentally start the task before it's meant to. So once I press the spacebar here, it goes to this waiting for scanner screen, and this screen is going to stay on until we receive that first TR trigger from our scanner. And so at Temple's scanner, that trigger sign isn't equal. Some scanners use a T. You just have to find out from your MRI text like which ones those are. But that way your timing is always synced up with the start of the scan, and it's not relying on like human error to try and match up your timing. So it's a really crucial component of your study when you're studying a neuroimaging design, or any study that like relies on that kind of like trigger or syncing up of time. And so now that's going to go through. And those are kind of the main components of any neuroimaging task, or even the task instructions that we would go through. So now the next thing I want to do is show you what that looks like on the back end of that code. And I'm going to go through that really quickly because I know we're short on time. Great. So this is that experiment code that I was telling you about. So one thing that I also want to point out here that I do is I create this kind of debug key or variable when I'm developing experiments in PsychoPy. The reason that I do this is because it can be really tedious. I don't know if you felt like it was tedious today when we were going through and running our experiment over and over and over to see if our stimuli was in the right place or that our logic was working correctly. And so sometimes I'll just have the experiment kind of automatically go through as if it was responding. I'll shorten some of those stimuli display times so that I can test it relatively quickly, but just make sure that the logic is correct. I would always recommend having someone else go through your code once it's ready or close to ready using the actual study timing when you're piloting, but this is a good way to just make sure things are working how you want them to before it's at that stage. I have all of these different timing components that we've talked about. I also utilize this date time library to timestamp things, so I can automatically record when a participant completed the task or when we saved out the data based on this timestamp. And then here is a good example of this kind of debug feature. So if I set that debug variable to true, instead of showing that dialog box that we learned about today, it would take all of the variables that we might want to record from the dialog box and just automatically assign them different variables. So I use that timestamp to create a random subject ID, and then all of these other information, pieces of information that I would use in my task. And then if we scroll down a little bit, you'll also notice here that there are two different log files that I've created. The reason for this is that in addition to logging response data using that output file or the CSV from the trial handler, I also use PsychoPy's own logging function and logging library. I didn't get a chance to cover that today, but there's a lot of extensive documentation on it. Essentially what that does is log any sort of activity that happens from our experiment code or our responses that we're collecting in a really, really long log file. But the reason that I like to have that is it serves as a backup to that output file and also provides a much more comprehensive kind of record of what happened during that run of the experiment. So if for some reason something goes wrong or some data didn't end up getting recorded, you should be able to kind of figure out what happened by parsing through that log file if you need to. And then the last thing I wanted to show really quickly was this save out function. So this is a function that I add to our global event keys that basically, if we've started a task and we need to exit out of it mid-run, we'll save any data that's already been collected to our CSV file in addition to that logging data. And lastly, I just want to show you what some of that code for that wait screen looks like. So you can see here, again, if we're debugging, I don't wait for that trigger. If we're not debugging, we use that event wait keys function that we learned about today to wait for that equal sign. And then again, we're resetting that global clock immediately after. So it sets to 0, the same time our scanner starts recording at 0 seconds. And so we can link them back together. And with that, I just want to say thank you for taking the time to attend and work through this workshop today. If you have any questions, feel free to reach out to me or send us an issue request on GitHub. But I hope this is helpful in developing some experiments, and thank you so much.